So our next speaker is Morgan Richards, who is he works at ValleyDAO as the product and tokenomics lead, and he's especially interested in entrepreneurship and how that can involve biotechnology, especially with kind of decentralized governments mechanisms like DAOs and using these investment mechanisms to accelerate translational research and hopefully maximize their impact on the world. So take it away, Morgan.
Thank you very much, Alex, for the introduction, and hello to everybody in the audience. Just getting set up, so bear with me 1 second. Put a background on as well. There we go. Okay, let me know if you can see my slides.
Yeah, we see the whole browser window. I don't know if it's supposed to be just the slides, but
Okay, it's in full screen mode now. Do you see that?
yeah, that looks good.
Okay, cool. Well, yeah, thanks again for the introduction. As Alex said, my name is Morgan Richards. I'm one of the co-founders of ValleyDAO. And ValleyDAO is a super interesting project if you're interested in synthetic biology, and I think super relevant for members of the Gogec community, given the focus on openness, inclusivity, and kind of this decentralized and global approach to conducting science. So I have a lot to talk about today. And I'm going to go through and try and cover the main details. Some things I might skim over in the interest of time. So if anything doesn't make sense, please feel free to pop a question in the chat or raise your hand and stop me. I'm more than happy to answer as we go through. But yeah, I'll try and leave plenty of time for questions in the end as well, as I would love for this to be more of a discussion than a lecture. So yeah, two main things I want to cover today are kind of an overview as to what is ValleyDAO and what is a DAO in the first place. And then on the second half of this presentation, I'm going to focus on what my work has been focusing on within ValleyDAO and the kind of product platform that we've been looking to develop for translational science. So without further ado, I guess I can introduce myself through a quick overview. So always start with a who am I? And this is just a list of my qualifications, which isn't particularly interesting. So just to give you an overview, my first degree, my bachelor's was in microbiology at the University of Liverpool. And then halfway through that, I got super interested in synbio and the applications of cell engineering. So I then went on to study MRes in systems and synthetic biology at Imperial College London. I was fortunate enough to be a DeepMind scholar for that program. So I had my degree funded by DeepMind, who were particularly interested in bridging the gap between AI and biology. After AlphaFold was released, they realized, hey, like there's a huge opportunity here for disruption. And so that was also a particular interest area of mine. And then currently I am the product and tokenomics lead at ValleyDAO. But stripping that all back, I like to simplify things. Like those are my qualifications, that's my background, but who really am I? Well, as many of you probably share this same identification, I'm someone who wants to learn how the world works and use this knowledge to improve it. Simple, right? But when I got to science and really started pursuing that career, I realized it's not actually that simple, and I was pretty disillusioned with why it wasn't that simple, right? So the idealistic example is exactly this. What it really looks like is this. And I've underlined the parts here that are like actually doing science. So you can see of the like many steps that you've got in this process, there's very few of those parts are actually science. The rest is all bureaucracy. It's all convincing people to fund you. It's sharing that knowledge, communicating it to sometimes a very small community of biased individuals. And yeah, it's pretty messy, right? Like the skills that you as a scientist are expected to hold that go far beyond research skills, go far beyond any analytical or data skills. towards like actually having to be this whole complete personality that lives and breathes science and can play the game by the rules of academia. So I won't like break this down. I'm happy to share these slides after this talk, and I believe it is being recorded as well. But as you can see, like there's a lot of convincing. So many of these steps say convince a sponsor, convince the rest of the world that you know how something works, convince a sponsor then that you can use that knowledge to improve it. Convince, 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 convince. And then you finally get to the end, right? If you're lucky, if you're very lucky, you can improve the world. But in that process, you usually make somebody else rich, right? Like the scientists are never the ones that are really winning, unless you go on to start a company yourself and take care of most of the business there. But that is in and of itself a whole different skill set, and one that they don't often teach you at university. So, you know, how do we reconcile this? But then within science, of course, there's many problems. And, you know, for what is a system that has produced a lot of value for the world, it's one that isn't without inefficiencies. It isn't one without things that could be improved. And I think the strange thing for me when I entered the scientific environment was seeing how intelligent, capable, analytical, and you know, strategic scientists are about their work, but not necessarily about the systems that are enabling them to do their work. So it's kind of, it was a strange juxtaposition for me. And so like, just to break down some of the big problems that I noticed when I came into it, is like biased funding, for example. So this diagram was released a little while back. And if I zoom in on it here, it basically shows the NIH grants that were given in 1980 and then the NIH grants that were given in 2013, right? And what you can see is the graph shape is almost exactly identical from 1980 to 2013, but it's just shifted to the right, which means that and this is like was a tweet that was given by Balaji, that it's basically just the same cohort of people awarding themselves all the grants. So it's easy to see from the outside that that's not a system that's promoting diversity, inclusivity, and isn't necessarily pushing us to answering the most pressing problems. Instead, it's, you know, people patting themselves on the back and giving their friends money to continue doing their work. So that's a huge problem. Another huge problem that I'm sure you're all aware of is the reproducibility crisis. So of almost 2,000 researchers surveyed, like 52%, so a significant majority, said that yes, there is a significant crisis. That 38% said yes, there is a slight crisis, and only 3% or 10% in total thought there wasn't or didn't know. So like almost 90% of the entire scientific field believes there's a huge reproducibility problem and that needs to be addressed, right? Nobody's really addressing this right now. We also have knowledge gatekeeping, right? So when you look at journals, and this one was really shocking for me when I found out how journals work, is that like all of the work pretty much is being done by scientists voluntarily. They then have to pay to publish, and then the viewers, who are also scientists, have to pay to read. Who gets that money? Well, not the scientists. The money goes straight to the publishing companies, who are essentially just curating the content. They don't actually own it. They're not producing it themselves in most cases. So it's a really extractive system. And where is that money going? Well, like it should be going back into research, right? It should be going to keeping the whole system alive, but it's not. So this was, I think, mid last year, the entire board of Elsevier walks out because of this very problem and the fact that it's just not being addressed. Like nobody's talking about it, and it cannot continue. So fortunately, there are some people working on this problem in particular, and there is like a slightly higher push nowadays towards open source publishing. But it's still, you know, if you want to get the most exposure, if you want to get the most recognition and reach career milestones, publishing in Nature is still the best thing you could do. But Nature isn't necessarily the best publisher in terms of how they are treating the ecosystem. Some other problems include the decline in scientific breakthroughs. This was quite a controversial paper that was released. So it's a hot topic of debate. But what it appears is that the disruptiveness of science is dwindling. Like we're taking less risks and we're focusing more on incremental research. So like for a time when actually, I mean, it's hard to imagine, right? Like our economy, even though it's not great right now, is actually better than it has been in most cases in the past, right? We are all mostly more comfortable and better off. We should be taking more risks. We should be doing more disruptive research. And yet it seems to be going in the opposite direction. And I think this speaks to some of the incentives and the problems that do exist in the academic environment, in that like it's a high risk job. You put yourself on the line, your reputation on the line. And if you fail to publish like once or twice, or you have some bad results, your entire job, like security, is in question. And so that creates this, as you can see, this incentive where like, actually, I'm not going to take risks. I'm going to do something that I almost certainly know will work, but isn't necessarily going to change the world or revolutionize the field of synthetic biology. Peer review is one I probably don't need to talk much about. Like it's another hugely exploitative process. Peer review is mostly done for free by scientists. And yeah, they don't get paid or compensated for that work. And it's hugely time consuming. It's something that everybody, like if they want to be recognized and reputable in the field, has to do. But they're, again, not being paid for that work. And the outcomes of that work, the peer review, again, goes towards the journals, right? Like it's work that goes towards an article actually being published in a journal, which is profited by the journal as well. And then the publish or perish, I think I kind of already alluded to this. The fact that if you don't publish, or if you're not producing valid results or interesting outputs scientifically, then your entire career and existence is on the line. So it really pushes people to be safer in their approach and think in less big terms, which I think is kind of sad. The next set of problems are more kind of systematic problems, or slightly more on the business side of things of science. So in terms of scalability and infrastructure, this is one that Symbio, I think, is feeling the most out of any of the fields. Like biopharma has capacity. They have huge bioreactors, huge companies that already exist that are pushing for the research, funding the research, providing the infrastructure to be able to actually do it and scale it to a commercial capacity. But we don't have that type of infrastructure in Symbio yet. It's still pretty early. And who's going to finance that, right? If there's no big players that are interested in it, other than, for example, Ginkgo, who have their own incentives as a private company. So this is a huge problem, and it's kind of the reason a lot of technologies don't go beyond bench scale, is because it's just too expensive, too complicated, and risky to try and scale it beyond that. We also have IP silos, so intellectual property, for example, that is created because there's an incentive of, oh, I discovered something, or I created a process or a technology. My instant benefit is to patent it, right? Then I can put that on my CV. I can say I've got 12 patents in this, this, and this. But am I really asking myself the question, does this technology need to be patented? Is it going to benefit the outcomes of what is done with this technology if I do patent it? And in a lot of cases, and surprisingly, this figure blew my mind, over 99% of all patents filed never recoup the cost of filing the patent. So in other words, 99% of all patented research doesn't get commercialized to any significant extent and just remains as a patented technology that nobody else can touch. So you can see how that creates a very obstructive landscape for innovation, when we should be pushing for more open and accessible innovation and creating the building blocks that other people can build even greater things on top of. And of course, it wouldn't be a Symbio talk without talking about regulation. Regulation, of course, it's inherently political. And so it's not uniform everywhere you go. The US, for example, has a much higher kind of appetite for GMOs compared to the European Union. And so how do we, as a global scientific community, reconcile that and make sure that we are doing things that are going to be beneficial and accessible to the most people. If I'm creating a technology that, yeah, great, it uses all these fancy symbio techniques and creates this amazing produce that is more nutritious and easier to grow and drought resistant, blah, blah, blah. That's amazing, right? But if only the US can actually use it and apply it, this creates an instant monopoly. And so I think there's a lot of consideration that needs to be taken there on creating regulatory frameworks that are more uniform and really considering the implications of exclusivity of technologies. But the even bigger problem in all of that is it's really hard to make systems level change. Like, we are talking about a centuries old system of working and conducting science, that there are many people who really founded this idea of how things should be done are still working in the field. They're still pushing the narrative. And because of the way that everything's been set up on the infrastructure side, on the organizational side, it's really scary to imagine that we would do anything any differently. And not many people are thinking like, let's take a risk, let's try and use an alternative model to solve some of these problems and create new incentives that are more beneficial for the collective as opposed to individual entities within the ecosystem. Now, this may come as a surprise, and honestly, it came as a surprise to me when I first discovered it, is blockchains actually are a potential solution. They're a potential technology that could be applied to creating systems level change. And they've done it once or several times before. And so just to give you an overview of what a blockchain is, it's essentially a cryptographic ledger. So if you can imagine a book where, let's say, birth certificates are all recorded, but this book cannot be edited. It's not written in paper, it's written in permanent ink. And once you write on the page, it cannot be overwritten. It is forever. And so the idea is creating this digital cryptographic network where you can create these records that once they're added can never be modified again. And so what you can do is create this immutable, and immutable means basically unchangeable representation of our current world state. Now, you probably, if you've heard of blockchains, you've probably heard of them in cryptocurrencies, which is just one application of how blockchains could be used. But because we're creating this algorithmic, programmatic, digital representation of our current world state, what we can actually do on top of that is design rules of interaction, what we call in the business incentives, rewards or penalties that can incentivize people to behave in a certain way or not behave in other ways. And so what I find really interesting is how we could apply this to many social problems and paradigms, not just in science. But as I said, it came as a surprise to me when I realized that actually this could be a potential solution for addressing some of those systematic problems in science. And so just to give a case study on how this works and how this actually changes things very significantly is Bitcoin, probably the one, if you have heard of any cryptocurrencies, you've all heard of. And what happened with Bitcoin is they essentially created a programmatic financial system, so a cryptographic coin that has an algorithm, and the algorithm is essentially defines an objective function. So what is the purpose of this coin, and what is it optimizing for? What is the algorithm optimizing for? The objective function in Bitcoin's case was to maximize the hash rate, which is equivalent to maximizing the amount of computational power in the network. So the more computers you have that are solving these mathematical problems in this network, the more secure it can be from outside attacks. So the idea was to just exponentially scale this, so you continue to maximize the hash rate, you continue to increase the security of the network, and so this money, this digital currency, becomes the most secure digital currency that you could possibly have. It worked really, really well, as you could probably tell by the price appreciation of Bitcoin over the years. But what is computational power equivalent to? Well, it's energy consumption. You need energy to power those computers. And so what happened is Bitcoin itself, as a cryptographic network, grew to the energy consumption equivalent to like the country of Norway. So suddenly out of nowhere, we had a like system, a digital system that's consuming the same amount of energy as an entire European country. Obviously, this is not a good case study, and I don't mean to say this to say like, hey, yeah, Bitcoin is great, but what it does show us is how quickly and how powerfully these games, essentially these digital games that we define, can really change behavior in the real world. So suddenly, like as you probably heard in the news, like China were buying up all of the graphics processing units because those were required to do the Bitcoin mining. You had to use huge computational networks to mine the Bitcoin and yeah, basically fill your pockets. And so they like this disrupted the graphics processing unit market as well. For years, you couldn't buy them anywhere. Like they were all sold out everywhere because China were buying them all on mass scale and creating these mining farms where they just had big, huge computer servers that were mining Bitcoin and making a ton of money. So what went from like this digital game of, oh, hey, like there's a very simple objective function, a very simple set of rules in this game, actually led to a huge social impact and real world impact in terms of energy consumption, in terms of like the market for an entire product. So what I find most interesting is how we could potentially use this to like do the same thing in science. If we want to really quickly create systems level change, then maybe let's try these types of games and see where we end up. And so this is kind of the focus of decentralized science. And the idea is to use this trustless incentives machine to encourage new and beneficial behaviors in society. So with Bitcoin, they didn't really think it through of like, hey, yeah, this is going to lead to more energy consumption, and that could potentially be a bad thing. But now we've seen that happen, we can start from the end, right? We can say, what do we actually want to achieve in the world? And how do we create the game and the rules and the incentives to make that happen? So there's a lot of work being done in various different areas, policy and regulation. DeFi is the finance world, so your crypto coins, your Bitcoin and Ethereum. Supply chain management is also another one that's really important to have immutable ledgers. Regenerative finance is an interesting one because they're essentially trying to create a currency that's based on the regeneration of communities and environments. Internet of Things, and then data and privacy as well being big ones, because yeah, right now all of our data is being used all the time and sold and transacted on. None of us get compensated for it. So blockchain people in the blockchain space are looking at how can we change that and create this new form of internet where you own your data and you can charge people for it. And then, of course, as I said, we are also in this space, in the DeSci space, looking at how we can apply these things to science. So first of all, we have to decide like what behaviors do we actually want to encourage and how do we want to encourage them? So just to give some examples based on our current incentives, we've got poor quality or unrepeatable data, because it's more beneficial for me to post something that's sensational and spectacular and exciting than necessarily post something that's true and just kind of boring. Following trends, so this is towards the incremental research, like people like doing CRISPR research because you're like 10 times more likely to get a citation in CRISPR research, not because the world needs necessarily more CRISPR research. We've got hyper competition, jobs are very competitive. And so, you get lying, you get stealing, you get cheating of the system. That creates a very toxic environment. Duplication of work is also something that results from this. People are racing to publish. So even though they might be working on exactly the same thing, it's better that I get there first and get all the credit for it than we actually just like, put our hands up and work together and achieve it twice as fast. So yeah, these are just some of the examples of the current incentives, but like, what do we actually want to encourage in a new idealistic scientific model? I think collaboration over competition is always of merit, especially in science. Like, we don't want to create. It doesn't necessarily have to be a capitalistic system where competition leads to more innovation and disruption. I think like it would be a much better world if we were all working together and singing from the same the same hymn sheet. We've got huge capacity in terms of intelligence, in terms of resources, equipment, networks, all of the things that you need to actually make really like massive change in the world around us. If we could better harmonize that and unify it, then I think we would have more disruptive science. We would want to also encourage the independent validation of data. So people that might not necessarily be directly involved in a project, but can like independently validate whether data is valid or not. And I think that would create huge implications for the amount of research that like actually has or is part of this reproducibility crisis. You know, the reason it exists is because there is no incentive for me as a lab that has nothing to do with anyone else, to go out and like repeat data unless I'm directly working on it. And by the time I get there, then I realize it doesn't work and the paper's already been published for 10 years. And people have built entire experiments and value chains from that. So something we want to incentivize for sure. Quality over quantity, I think, is always better. So rather than having 10 publications, incentivizing people to have one really high quality one that gets rewarded proportionately, rather than it just being based on the number of citations, which is a pretty arbitrary number. Permissionless knowledge sharing, I think, is something that would be very beneficial to science as well. So being able to share knowledge across institutions, across geographies, and yeah, not having that gatekeeping by the publishers. And then, yeah, creating a reputation system outside of academic merit. So like if publications and patents aren't what we measure our success or like value of a researcher on, what else could we look at? And how could we do things that are more reflective of their value and contribution to society, as opposed to like these arbitrary numbers that we can measure? And this is just like how decentralized science and the DeSci community is supporting these through the creation of decentralized communities, protocols, funding, and digital primitives. So the key word always being decentralized. We really believe that this decentralized approach is what like holds the key to solving many of these problems, because the more stakeholders you bring into a conversation or bring into a discussion, the like more representative of or the more widely representative that discussion is of people's opinions, of people's needs, and how things should be developed in the scientific ecosystem. So here we have the DeSci landscape. So like ValleyDAO is one project within decentralized science, but as you can see, there are many, and this is actually, I think, a year or two old. 2022, yeah, so it's 2 years old almost already. So this is like more than doubled in the last 6 months even. Many people are working in this field now across different, trying to tackle different problems. So from data storage and protocols, publishing, financing, ecosystem building, biotech, open science, communities, and then we have DAOs. And DAOs is this new concept of basically creating an organization that is community driven. So rather than it having like, you know, central leaders that make all of the decisions, really opening up that decision making process so that more stakeholders can be a part of those decisions. And in the case of ValleyDAO and many of the DAOs that you'll see here, that key decision is on which projects should we fund, where do we apply our resources, our time, our capital to make a difference in the scientific ecosystem. And so one key digital primitive is these IP-NFTs, and this is a technology that ValleyDAO uses as well. They were developed by Molecule, and they basically convert intellectual property agreements into an NFT. So an NFT is kind of similar to what I talked about earlier with cryptocurrencies. It's a non-fungible token. So you have a digital like artifact. In many cases, it can be an image or a piece of art. But essentially, you create this digital signature that says, like, this is the original copy. And you can create 100 original copies and sell each of those, or you can create just one. But the idea is that, like, I could theoretically copy a JPEG or an image, but that doesn't mean I own it, right? And so this whole like NFTs principle is about proof of ownership, to prove that you are the real owner of that. So somebody theoretically could copy it, but I could dig deeper and find out that, oh wait, they're not actually on this blockchain. They don't hold the key to this NFT. Why is this beneficial for intellectual property? Well, one of the things I talked about earlier was that we have these IP silos, and one of the kind of key reasons and issues is that IP is not like, it's not internet native. It's not set up in a way that is optimized for other people to come in, collaborate, discover it, develop or co-develop on it, and like use it as a building block, which is essentially what IP should be, right? Especially in SynBio. So if we're thinking about cell lines, we're thinking about metabolic processes, all of the like bioreactor designs, like these should be the modular building blocks that we're building this revolution on. And yet the IP is still like pen and paper agreements that have to be dug out. You need specialized skills and consultants often to actually find it, to understand it, to communicate about it. So it's just like this really hard to crack black box where, you know, if we had things more like, if we like use the analogy of software development, like you have components, right? You have a library of components. People have interacted with it. They've reviewed it. They've validated that it works. They've used it in different contexts. And this creates this much more rapid cycle of innovation. The other thing that IP-NFTs do is enable you to like transact and fractionalize intellectual property. So I can now, like, for example, sell my IP online to somebody through this blockchain network. And it can be as simple as like a 2-click process. So I can then transfer them the like legal ownership of that intellectual property. And they become the new owner. And like suddenly something that takes like weeks, sometimes months of negotiations between companies can be done at the click of a button, provided, you know, both parties are agreeing to the terms. And then this fractionalized component is like, how do we break it up? So as I said, you can mint like one IP NFT, or you can mint 100. So if I mint 100, that doesn't mean that I now have 100 times the amount of IP. It means that the IP has been divided into 100 pieces. So if I sell one of those 100 pieces, I'm selling 1% of the IP. And that can be reflected in the royalty shares when the IP is sold to other parties or licensed. So me owning 1%, I'll get 1% of the like the fees that are collected from that. Or it can be a more focused on the governance of the IP. So if a group of 10 stakeholders co-develop a piece of IP, they can all have decision-making power on what is done with that IP, and yeah, how it is used. So rather than a single company saying, hey, yeah, we want all of this, and like we're the only ones that can use it, those 10 stakeholders can maybe get together, they can argue, they can discuss and vote on the blockchain, which is a very transparent way of doing things. And as I said, immutable, so nobody can game that system. They can vote on like, hey, actually, we're going to open this up, or we're going to sell it to this company, but not this company because we don't like what they're intending to do with it. So you've created this mechanism of much more openness and transparency in the approach. So all of that to say, who is ValleyDAO, right? So ValleyDAO is an organization who I can't say that word, who envisions a future that leverages biology to create a more sustainable world. So our focus, and the reason I'm here today, is synthetic biology, particularly for climate and food security applications. So what do we actually do? Our community accelerates the development of new technologies in SynBio through, and these are our 4 kind of main impact areas. So funding and supporting translational research. So we will actually fund research projects at academic partners, and then support the incubation and translation of that research once the technology is developed. Incubating technologies into impactful climate solutions, as I said, our like really important thing is how do we get more of those technologies out of the lab and into the real world, impacting people's lives. Widening participation and creating new incentives for collaboration. So addressing some of those systematic problems that I spoke about earlier. And then finally, building global scientific communities. So ValleyDAO is an open community. Any of you can join, and I'll share the link for you guys to join later. We also have a Discord. So if you're familiar with Discord, then that should be of no issue. But we're not trying to like locate ourselves to any one geography. So we are interested in the research and work that's going on in Africa, Latin America, Asia, Australia, like all of these places that often get overlooked, but are, like hot hubs for innovation and like have high potential research going on there. So how do we do what we do? As I said, we are a decentralized organization. That's what the DAO part stands for, Decentralized Autonomous Organization. So members can decide the direction of the organization. What do we fund? What do we not fund? What do we do with the IP? Which terms do we accept or negotiate when dealing with tech transfer offices? And this enables like a higher incentive alignment. So what happens is anyone that contributes to any of the growth groups in the ValleyDAO community will be compensated in what we call the Grow token. Now, the Grow token can be used as a governance vote. So the more Grow tokens you have, essentially, the more you've helped the community, the larger your influence over a decision will be. And that's really to push, as I said, this systems level change where people are more incentivized to work and support the collective as opposed to individuals. It also enables the pooling of capital, resources, and network. So in the terms of capital, the token can be bought and transacted on. It's like available on a cryptocurrency exchange. So if you wanted to help fund the research, like you could buy a bunch of Grow tokens and that will go into the collective treasury that can then be used to fund research. The other thing is application of resources. So resources can be like human capital, for example, or it can be like, hey, I've got like some lab space that I'm not using through like March to December. Does someone want to come and use that and like run an interesting project for a low cost or free of charge? So having this like unified community really enables you to unlock things that, like go back to this model of favors and collaborating rather than like, oh, like you owe me something for doing this for me, because we're all actually working together to grow the mission of synthetic biology for climate. And then, yeah, as I mentioned, the IP sharing. So IP from funded research is governed by the community. So the IP-NFTs are fractionalized, and then everybody with a Grow token can vote on what we do with it next. And the idea is to really create research that's conducted for the benefit of the ecosystem and not the individual. So this is just a diagram of how the system actually works. And yeah, basically just shows how our funding system is operating. So if I just zoom in here, ValleyDAO as an organization or community will fund and give translational support to SynBio researchers. Once that IP is generated, it can be licensed or a startup can be formed. Proceeds and equity obviously go back to the researchers that contributed to the project, but also some of those proceeds and equity will go back to ValleyDAO as a community. Now we're a non-profit, so we're not looking to like make huge exits and like line all of our pockets. The idea is that the proceeds and equity that's generated from ValleyDAO goes back into funding research. So if we fund a moonshot project that ends up becoming a unicorn biotech company, then suddenly we've got a lot more capital to allocate to new and interesting projects. So we want to create this sustainable funding loop that doesn't really exist in the current model. And then, as promised, the last thing I want to give some information on is Flow. So what is Flow? It's our product platform that we're looking to develop that really enables this community-driven research translation. So the first thing is to differentiate between like Forager style science and goal-oriented science. So Forager style science is what I like to think of as like very exploratory, early stage work where you're kind of going out into any random direction and seeing what you discover. Now, on the opposite side of that, you have goal-oriented science, which is really what ValleyDAO and like many of these DeSci DAOs are focused on, is having already an objective in mind. So in the case of us, we would like to address climate and food security issues using synthetic biology technologies. We know what direction we're headed in. And so we're not just going to be out there doing any random thing. We really know what we want to work on and what's important to us. And that differentiation allows us to create some structure that you may not see in some of the other organizations that are out there. and kind of resembles what a focused research organization may be doing as well. So how do we think about like creating the structure and process? Well, we're thinking about technology trees as being like these roadmaps into the future. So as you can see here, we've got our little ant diagram, and it knows the rough general direction it's going in, but obviously there's multiple potential pathways. The red one represents the one that actually works, right? So we as a scientific community can at least look like, 6 months, 1 year ahead and say like, what are the key challenges? What are the possible pathways that we could take? And what are the key obstacles that we need to avoid? Obviously, this is a big simplification. It's much more complicated than that. But this is the lens that we're trying to look at the scientific landscape through and create these technology trees. And then the final component is the consolidation of those viable pathways. So once we discover like, oh, this will actually work, how do we create a strong signal in order for the ants, the next generation of ants that come along, they don't have to like answer this question. They can just follow the diagram. So that's how we see these technology trees as becoming roadmaps into the future. So we've used the example of ants because of how ants use pheromones, right? They go on these random trails. Some of them may yield fruit, some of them may not. But eventually they like come back over the one that like worked to create a stronger pheromone signal for the next ants. So ants don't all like get to a crossroads and say, oh, which way should I go? And then pick a random direction. The next generation of ants all know exactly where to go because the signal has been consolidated. So this like diagram gives you an overview of how that happens. And then when this next ant comes along, it's high signal, low noise. There can be scaled deployment of resources. So if that ant, that new ant is a funding body or a VC, for example, they don't have to like, ask again the question of what's interesting, what works, what doesn't, what are the risks. They already know that. So they can just like efficiently and quickly deploy capital and resources to solve those bottlenecks. And so like this is an example of what a Forager style tech tree looks like. And why is it a Forager style tech tree? Because you've got like, let me try and zoom in on this. I'm sorry, it's not super great quality. But yeah, essentially you've got like these topics, you've got subtopics, and like all you can really do with this information is read it and get an overview of what's going on. And so what we want to create is this more, like I said, the ants structure where we can create signal to like and apply that signal to these technology trees. So rather than just having a bunch of information that is all equally relevant or irrelevant, we can create signal that shows you like, okay, what problems actually need solving, what stage are they at, and what is needed to overcome those problems. So what we call them is the more focused goal-oriented tech tree. And so this is just like a high level question of what's the difference between a sensor and an agent. And if we think about these Forager style tech trees kind of being like sensors, they report on data, they report on information that's out there, but they don't do anything more than that. What we want to create is agency with these technology trees. So you can come in and you can apply your skills, your background, your knowledge, and your resources to first understand the current world state, which is the sensor part, and then having a desired future outcome, which is your goal. So you can find that pathway from A to B. And anybody in the communities can come up with that as well. So we went through some examples of this using a platform called the Coordination Editor, and really tried to look at how can we break down a complex scientific problem into smaller, more digestible problems. And yeah, like actually start to like instruct community, a decentralized community of people to solve in those problems. And so we only got so far with this. This was just like a platform that we used for experimentation. But what we're trying to do now is create our own bespoke platform for exactly these purposes that allow you to leverage LLMs to help aggregate, synthesize, and structure the information. So what we call the creation component. You can allow the community members to vote on and consolidate additions or like give signal to those, give signals to those pathways, which is the curation component. And then we can synchronize versions. Maybe people want to create their own version and like actually, create alternative pathways. And we call that the decentralization component. So in the interest of time, I'm not going to go through these, but just want to explain like why is this useful and what could it be used? Like what are the potential use cases of these technology trees once they're created? So the important thing to note is, as with a cooking recipe, the ingredients you use determine the amount of the types of recipes you can cook. So what's really important in these tech trees is like knowing what data should we report on, what things should we know in order to create high quality signals that help us actually solve problems and know what can be done. So these are some examples. Obviously, we have research papers being the simplest. Summaries or communications. So these can be articles, people's own theses, like that they've written about a field, maybe their literature reviews. Authors or researchers, of course, we want the people, the agents, to be linked to this system and know what all of them are doing, what are their interests, how are they contributing to the field. I think the key nut to crack here as well is the funders, and we've spoken with a lot of people that say like, we just want to know, like, if we do some complex collaboration, how can we even fund this? Like, how is it going to work? How do we break up the work packages? How do we break up who benefits from what? And like, what stake does everybody have in the final outcome or the product? So that's a super interesting one as well. TRLs, so technology readiness levels. These are kind of like a status update. So we can see like, okay, at what stage is this research? What next problems need to be solved? And like, who are the stakeholders that can come in and actually solve that bottleneck? So if it's a TRL where like scale up is the next problem, we're no longer talking about an academic research lab. Like we need a very focused group of people that have expertise in scaling up those processes. And so it's a completely different game. And having visibility on like, okay, this project is ready for those stakeholders to come in and make a difference would be really beneficial for them, as well as the project itself progressing, rather than having to find them all manually yourself. Impact or scale metrics, so having an idea of like what is the actual impact and the final outcomes that are created from the projects. And then patents and IP as well. So having an idea of what IP and technologies already exist and could be used or reapplied to solve those bottlenecks. So yeah, I'm not going to show this one either. It's just an example of how the strategic tech tree would look. And yeah, so how do we get there? So this is how we're thinking about designing this ecosystem. We have our information layer that we're calling layer 1, which is like bringing together the collective knowledge of all of the stakeholders in the ecosystem and creating these technology roadmaps. And then once we have that, how do we map like the activity layer, or what we call the application layer, layer 2, to that, so we can actually understand like what is happening, what needs to happen, and how can all of these stakeholders come in and collaborate together to solve those problems. So like one example of application is just networking, bringing together nodes and groups of people that are interested in the same things or working on the same problems. It's a low-hanging fruit, but unfortunately, besides LinkedIn or ResearchGate, doesn't really happen, and there's no real bespoke platform for creating these communities and like operationalizing them, giving them the tools and capabilities to actively go out and work together and solve problems collectively. Then, as mentioned, the funding component, super important that people have access to funding and that it's not this hugely competitive bureaucratic process and people could just get the work done. And then literature review, like actually understanding what's happening, what quality, and yeah, what can be done in the future. And then this one was a question mark that we've thought about, but also find quite interesting, is layer 0. So underneath the layer 1, the information layer, like can we have agreed upon sources of scientific data, metrics, and variables that can be imported as what we call oracles from other sources? So things like the amount of CO2 being emitted by heavy industry. Like if we want to work towards a certain goal and we want to quantify that goal, then we need to know what that number actually is. And as research happens over time, we need to be able to update that number because, if we're 50% out, we're aiming for something that ends up being 50% lower than what we had expected. or sorry, if we're aiming for something that ends up, if we're aiming for a goal that's 50% lower than the reality, then we're not going to achieve our goal, right? Like if we're trying to decarbonize heavy industry and we have in mind one figure and we aim for that and we achieve it, great. But if the actual emissions are twice that, then we've still failed on our goal. So it's really important to have these agreed upon destinations, essentially, that we can use to inform our decision-making processes. And so what are we doing at the moment? Well, we're working with some key stakeholders to create a pilot program for this, and yeah, enable people to collaborate on these tech trees and actually solve research challenges together. So if that's something that's of interest to you, or anyone that you know, then feel free to get in touch with us. That QR code will take you to our website, where you can see our Discord channel. You can join the community and introduce yourself. And if anyone wants to get in touch with me as well, my Twitter and Telegram are on the right-hand side. So Multiplex on Twitter. Oh, that's actually a typo. It should be MXLTI Plex. So Multiplex, and then my Telegram is Multitude. So yeah, want to stop there. I know that was a lot of information. So if anybody has any questions, then I will be more than happy to answer.
Thanks. That was a really interesting talk. So if anyone has any questions, you can use the reactions to raise your hand. And also, I have a couple questions, I think, since it was really interesting. So one thing I was wondering is, you pointed out a bunch of these kind of like DAOs and similar organizations popping up around the world. But it seems like it still isn't kind of taking over the mechanisms of science yet. But I guess what signs do you think we would look for if we were seeing like a major shift? Because it can't just be like, oh, we see some organizations. I guess, what do you think the indicators would be for that?
Yeah, I think the biggest indicator, at least in terms of our league of organization, is we're a funding body essentially. So the more money that's coming into the space and the more money that's actually going to funding research, I think are the highest indicators of the critical mass that's there. And then another one that's kind of loosely tied is the token price. So it's kind of an abstract concept, but the more people that are interested in a project in crypto, the more they buy the token, right? And then that influences the price of the token because supply and demand mechanics. So as the token appreciates of a project, quickly and drastically, you can kind of reflect that as to the general interest in supporting a project of that type. For example, in December, we had a massive price appreciation in our token because people suddenly became really interested in DeSci in the crypto community. So that's it's a window because those are usually crypto audiences and not necessarily the scientific ones. But then that leads to downstream us having more resources to invest in the research, and then ultimately, more dollars spent on research would be the indicator.
Okay, cool. And then I had a question about kind of the grow token, and so I know that you were saying that you get more kind of votes in the DAO as you get proportional to the amount of grow token you own. Is there any sort of risk that there might be like a takeover of it or over centralization if only a couple individuals or like a certain consortium of people purchase a large portion of the available grow token? Could they then basically hijack the organization and re-centralize it based on their own goals or something? Or the mechanisms to prevent that?
Yeah, great question. So this is actually my second role within ValleyDAO that I didn't really talk about because it's abstract. But tokenomics is my other area of expertise. So one of the things that we had to do is we had to actually design the tokenomics and make sure that it didn't allow for those things. So one of the things that we did at the beginning was to find okay, who are the key stakeholder groups and how do we ensure that they have enough of a say and influence in the beginning because they came in early, because they were instrumental to us even getting to where we need to be in the first place, but not giving them too much that they can, as you said, centralize and have significant control or sway over the organization. So even us as founders, I think we have a total of 6% of the entire token supply. which if you compare that to equity in a company, like that's just unheard of, right? Like founders will have 50% or upwards of the company. So like we see ourselves as stewards and not necessarily the people that will always be like leading the organization. So we didn't want to have it so that when we leave, we're taking a whole chunk with us. Instead, we want like the community to own most of it. So we also had like when we first raised or launched the token, we did a community auction. So anybody was able to participate in that. And yeah, like I think 3 or 3.5% of the supply was auctioned off to the community. And then the final thing to say is based on the design of the tokenomics, the supply and demand mechanics, essentially someone could come in and try to buy a 51% share of the token. Now that would especially at this stage, our treasury is small, the amount of like assets under management is pretty small. It would be prohibitively expensive to do that and not worth, it wouldn't be worth it for anyone. And what would happen as a side effect is that everybody that currently holds the token would see like 100x increase in their token price. And then they would just theoretically sell those tokens. And then suddenly the treasury value goes back to 0 again. So if that happened, the community still wins, right? Like everybody that's been contributing and actually making things happen still benefits the most from that. And we would just, start a new token or form a new DAO or something like that. So yeah,
so like someone could take over, but it would be a bad idea for them economically. And then the end result would basically be all the people involved can just take the money that someone just paid them a bunch of and then leave and do something else.
Exactly. So that would also be beneficial for science anyway. So we would still achieve our mission.
Okay, and then I had one more question about the IP NFTs, because I know that or a large portion of kind of the traditional art NFTs don't actually contain the art themselves. They just contain like a URL that points to like a server that contains the artwork or something. So I was wondering, what do these IP NFTs actually contain? Do they contain like contracts in them that would be like, oh, that say, oh, if you own this, or like the deed to a house sort of thing, or do they contain some indicator that points to some registry that says that you own it, or what do they? How does that work exactly? I don't, you don't need to get super technical, but
it's another great question.
It's a kind of technical question.
So I think the key thing that maybe I didn't mention but is important to note is like these IP NFTs are not a replacement to like intellectual property contracts or agreements. So you still have a patent that's registered legally through the entire normal process. What the IP NFT does is exactly as you said, it points to that agreement. And then it enables you to modify that agreement in terms of I could change ownership of who actually owns this IP. I couldn't change the inventors or who's originally signed on to that document, but I can say, hey, I am the new owner because I've sold it, and this transaction can be traced transparently.
So is that automatically included? That's a condition of the legal constructs that when the NFT is sold, then that inherently links it to okay, well then legally that means that now you own this IP. Okay.
Yeah. So the fractions give a governance ownership. So it basically says that whoever owns the majority share of the IP has the decision-making authority. And then there's still a layer of trust, right? We're talking about things that are being applied in the real world. You cannot put a gun to someone's head and say, you must do this with this IP. But there are legal implications if they do or don't comply with those rules. So it still goes through all of the normal legal processes, but what it's really enabling is the I always struggle with this word, digitization of intellectual property, in the same way that we're trying to digitize currencies as well, because it means that someone cannot now come to me with a gun with my head and actually rob me for everything I'm worth. It's digitally secured, and that's why it is, in my perspective, an inevitability that financial systems move towards this. In the same way, I think the having IP as a digital asset enables some things that are just not possible with the current system. So it's not about replacing it, but it's about augmenting it and making it more efficient and better. And and yeah, achieving the scientific outcomes more effectively.
Okay, yeah, no, that's really cool. Did anyone else have any questions? Okay. Thank you, Morgan, for speaking. I know our audience has been a little bit, I think, because it's been getting later over time, but we really appreciate you speaking. And yeah, people can check this out on YouTube when we upload it later, I think. Yeah,
Yeah.
thanks.
Thank you so much for inviting us on, and thank you everybody for listening.